In this video, we are looking at how can we get the probability for the standard normal distribution. And we will use example 4 to illustrate how can you get the probability for z-score or standard normal distribution. So the first question, we are asking for the probability for z smaller and equal to 0.25. And the second question, we ask for z larger than 0.03. And the last question, we are looking for z larger than 0.03 and smaller than 0.25. So please open the blank Excel file. So here, before I start to teach you how to get the probability for z-score, I want you to look at the standard normal distribution. So here is a standard normal distribution with the mean equal to 0 and the standard deviation equal to 1. So any time if we are looking at the probability distribution, and for the Excel, what they are looking for is you first type in the value for the z, and then they will start to calculate the cumulative probability distribution. As we know, the probability for the continual probability distribution is the area under the curve. So once you plug in the value, and they are starting to calculate the area under the curve from the negative infinite to the value you plug in. So here, first question, we are looking for the z smaller and equal to 0.25. So which means we tell the computer, okay, we are looking for here, the maximum value for x is 0.25. Can you help us to calculate the area from the negative infinite to 0.25? So the function we will use is equal norm.s. S stands for the standard, the dist means distribution, and parentheses, the z-score, as I mentioned, is equal to 0.25, because if you can go back to look at the question, z smaller and equal to 0.25, and common, and we'll type in true because we are looking for the cumulative distribution, close the parentheses, and 0.59876. So that is the probability for the z smaller than 0.25. So the second question is asking for z larger than 0.03. As I mentioned, if you type in normal, the dist, in parentheses 0.03, common, true. So actually what you are doing here is you are calculating the z smaller than 0.03. So that is not what we want, because we are looking for z larger than 0.03. So you need to do one more thing, because we know the z larger than 0.03 is the complement event for z smaller and equal to 0.103. So what you will do is 1 minus the 0.511966. So the probability for z larger than 0.03 is equal to this number, 0.488.34. So in order to get, which means in order to get z larger than 0.03, you need to use 1 minus z smaller than 0.03. So now let's look at our last question. Z larger than 0.03, smaller than 0.05. So in order to get the probability for that one, you need to know actually the z larger than 0.03, smaller than 0.05 is equivalent to calculate the probability z smaller than 0.25 minus the probability z smaller than 0.03. So as we already calculated the z smaller than 0.25 from first question and the z smaller than 0.2303 from the second question, what we want to do now is we will use the first question answer minus the intermediate answer from the second question, z smaller than 0.03, and we got 0.08674. So that is the probability for z larger than 0.03, smaller than 0.25.